Okay, a little bit for prep tonight on arcs and sectors of circles. So hopefully you all know what this is. This is a circle. Obviously you know the perimeter, the area. If I were to draw two straight lines like this, I split this circle into two sectors. This one in here is called the major sector. And this one in here is called the minor sector. And I also split the circumference of the circle up into two arcs. This bit here is called the minor arc, and this bit, you probably guessed, is called the major arc. And within this, we've split the circle up into kind of two different parts. And what we do when we're talking about these is we call the angle here in the circle. So this angle in our sector, let's call it that one. So if this angle in our sector is theta, the area of that sector, so the area of the sector, and I'm going to be talking about this minor sector now because that's the angle I'm looking at. We could have labelled the bigger angle, but the area of the sector is just a fraction of the area of the whole circle. So the area of the whole circle is pi r squared, isn't it? So the area of the sector is going to be theta over 360, because that's the fraction of the circle we're using, times pi r squared. And the length of the arc is simply going to be theta over 360, that's the fraction of the circle, times by the circumference of the whole circle is pi d, or 2 pi r. Okay then, let's look at a quick example of how we would use this then. So if I had a sector of a circle, and the sector has an angle of 60 degrees, say, and the length of 3 centimeters. And I want to work out the area and the arc length of this sector. Well, the area is pretty obvious to begin with. So for the area, we're just going to do angle divided by 360. So what fraction of a whole circle have I got? Times pi times the radius squared. Now, sometimes they ask for this as an exact value. So if they ask for it exact, when they say exact, it means leave in pi. So if I imagine they were asking me to leave in pi here, that's a sixth times pi times 9. And a sixth of 9 is 3 over 2 pi centimetre squared. So that is it in its exact form. So they say leave your answer exact or leave your answer in terms of pi. They mean just leave it like that. You could obviously type that into a calculator and work it out. And the arc length would simply be 60 divided by 360 times 2 times pi times 3. And again, that's 1/6 times pi times 6. That's just coming out as pi centimeters, and that's it exactly again. Obviously you could type that into calculator, 3.14 if you want it as a decimal. Just be careful here. The only thing I'll say, if they ask you for the perimeter of this sector, so let's say they asked you in this one for the perimeter of the sector, this length here is the bit we've found out is pi. Remember, that's the centre, so this length is also going to be 3 centimetres. So the perimeter will be 3 add pi. And that will give you 6 plus pi centimetres would be your whole perimeter if we do it exact. So just be careful of perimeter, it'll ask you for the little edge bits. Okay, for the last bit of your prep then, can you just have a look at these 4 questions and have a go at finding the arc length and sector area for the minor So they're asking for the minor sector area and the minor arc length, so it's the smaller one each time. I suggest you just pause the video now and then keep it up on your screen while you have a go at those 4. And when you're finished, that's it for prep. Just make sure you have calculators and things tomorrow. You're going to be doing some work on these sectors and some problems in these in the lesson.